Now that we've seen these four rules of logarithms, let's look at a few examples of how they might be used. One thing that we might want to do is take multiple logarithms and combine them together into one logarithm. For instance, say we had the log base 5 of 2, and I'm adding it to the log base 5 of 3. Well, since they are the same base, and I'm adding them together, it really looks like rule number 1 here, the log of m plus the log of n. As long as the bases are the same, you can combine those two things together into the log with the same base, but the argument, the thing that you're putting into the log, is m times n. So we could say this is the same as the log base 5 of 2 times 3, 6. That's a pretty basic example. Let's look at another one. Say we were doing 1/2 the common logarithm, log, of 25 minus the log of 2. Well, we've got subtraction, so it looks like maybe we should be able to use rule number 2. But we can't yet, because rule number 2 says log minus log. And there's no numbers, there's no coefficients in front of these logarithms. And I do have a coefficient here, so I can't combine these as they are right now using rule number 2. But we can do something with just this first logarithm by using rule number 4. Rule number 4 says if you've got a coefficient out in front of the logarithm, that's the same as having that same number as an exponent inside the logarithm. So, in other words, this 1/2 of the log of 25 is the same as the log of 25 to the 1/2. But what is 25 to the 1/2? That's 5, because the 1/2 means square root, and so we're taking the square root of 25. So this becomes the log of 5. So the 1/2 out front became an exponent inside the logarithm because of rule number 4. And then all we've done between here and here is just simplify what 25 to the 1/2 is. 1/2 means square root, so we turned it into a 5. Then we still have this log of 2 that we were subtracting at the beginning. And now this looks just like rule number 2. The log of m minus the log of n. In this case, m is 5 and n is 2. So we can combine these together into one logarithm that is m over n, 5 over 2. And so the log of 5/2, or 2.5 if you like it as a decimal, is the same as 1/2 the log of 25 minus the log of 2. Since we've got numbers, it's not a horrible idea to actually confirm this on a calculator. If we take 1/2, so 0.5, times the log, common log, of 25, and we subtract the log of 2, we get this number, 0.397940, blah, blah, blah. If we do the log of 5/2, the log of 5/2, we get the exact same number. This right here confirms for us that this original expression and what we simplified it down to are in fact the same thing. Let's look at another example here. If we see something like, we're going to introduce some variables in here, the log base 6 of m plus the log base 6 of n minus 3 times the log base 6 of p, and we want to turn this whole thing into one single logarithm. Well, we could say these first two, according to rule number 1, we'll apply rule number 1 to those. Since they have the same base and we are adding them, we can take those first two and make them into the log base 6 of m times n. And at the same time, we can say this last part is 3 times the log of p. We're going to use rule number 4 on that and say that thing turns into the log base 6 of p to the 3rd power. That's rule number 4. And we've got a minus sign in between those. So now we can combine the two of these using rule number 2 into a single logarithm where, since we're subtracting, the one before the minus sign becomes the top of a fraction and the one after the minus sign becomes the bottom of the fraction inside the logarithm. mn divided by p cubed. As an informational note, one common mistake that I will see here is we'll forget where the fraction goes. This is not the same as saying the log of mn divided by the log of p cubed. This is the correct way to apply rule number 2. This is really no darn good. So be careful when you apply the rules, especially rule number 2. That's the one that I usually see the mistake happen on, is we try and turn it into 2 separate logarithms in a fraction. It's one logarithm, and the fraction is what is being inside that logarithm. Let's do one more where we work the other direction. If I've got the log of the cube root of m times n, and I want to break this up into individual logs where the logs are just log m and log n. Well, first thing I would do is I would say, hey, that cube root is really an exponent of 1/3. And since both the m and the n are inside the cube root, they're both being acted on by the 1/3. And then I might apply rule number 4. Rule number 4 says if you've got an exponent inside there, it can come out front of the logarithm as a coefficient. And now it's not inside the logarithm anymore. And then we might say, hey, I've got 2 things multiplied together inside the logarithm. We can break that apart using rule number 1. This, according to rule number 1, becomes the log of m plus the log of n. But remember, this 1/3 was being multiplied by that whole thing. So this whole thing is then multiplied by 1/3. So it works in this direction too.